Hi everybody, this is Ms. Kabani from Saxe High School. Today I'll be talking to you guys about the combined gas law. And it's called the combined gas law because it combines Charles's law, Boyle's law, and Gay-Lussac's law all into one formula. And this equation is really useful when you have initial conditions and final conditions. So a lot of the times the problem will tell you, okay, the pressure was initially this, and then it rose to, let's say, 5 atmospheres or what have you. So what to look out for in these problems is that you're going to be given two sets of conditions. And you have to look at what is the beginning condition, that's all the ones, and what is the final conditions, and we note that as 2. Okay. Also, what's really neat about this equation is that if something is held constant, meaning it doesn't change at all, you just kind of ignore it in the problem. Okay. So, for example, each of these variables, okay, P is pressure, V is volume, N is the number of moles, and T is the temperature. Okay, so this set is all the initial pressure, initial volume, initial temperature. Okay, this is the final pressure, the final volume, all that. Okay, but if one of these is constant, you don't really have to worry about it in the problem. Okay, for example, a lot of the times the number of moles, N, will be constant. Okay, so we kind of just ignore it in the problem. I'm going to show you what I mean by that as we do some of these together. Okay, so in your practice packet, okay, so I'm on page 5. Okay, again, this is the combined gas law noted for you again. And just a reminder that N is the number of moles. Okay, that's just the quantity of gas. Okay, so if a variable does not change or is not addressed in the problem, leave that variable out of the equation. Again, you just have to ignore it. Okay, so you're gonna first cross multiply and then divide. Okay, a lot of the times in your geometry classes or your algebra classes, they call this the butterfly. So you cross multiply each side and then you divide. Okay, so you're pretty much looking for what information you have. And you have to read them carefully because it's going to tell you what is the initial condition and what is the final condition. Okay, so here it says if I initially have a gas at a pressure of 12 atmospheres, okay, well I know that's my P1 is 12 ATMs. The volume is 23 liters. The temperature is 200 Kelvin. Okay, then I raise the pressure to 14 atmospheres. Increase the temperature to 300. And they're now asking what is my new volume of gas. Okay, so I am essentially solving for V2. Okay, now they make no mention of the number of moles. So in that case, it's held constant, or we just don't need to worry about it. Okay, so don't even worry about N in this case. All right, and when you plug it into this formula, you're not even going to put anything in for N. Okay, you're just going to leave it alone. All right, so I'm going to plug all of these variables into this formula. Okay, so my P1 is 12. My V1 is 23 over my initial temperature is 200, which is equal to my final pressure is 14 times V2, that's what I'm solving for, over 300. Okay, so now algebraically to solve for V2, you're going to cross multiply and divide. So I'm going to take all of these, multiply them, and multiply these, and then I'm going to solve for V2. Okay, so what that looks like is 12 times 23 times 300 is equal to 200 times 14 times V2. Okay, now to get V2 by itself, final volume by itself, you're going to divide by 200 times 14 to each side. Okay, so I know a lot of you might not have a calculator at home, so I'm sure most of you will be using your phone calculator for this. So in the spirit of all of this, I'm going to be using my iPhone as well. Okay, so I'm going to do 12 times 23 times 300. Okay, and that's 82,000, whoops, 800. Okay, then I'm going to do 200 times 14. So that's 2,800 V. Okay, and now to get V by itself, I'm going to divide 2,800 to each side. So we're going to do 82,800 divided by 2,800. And that gives me 29.6 liters is my final volume. Okay, so this canceled out and I'm left with my final volume. Okay, so again, my unit is going to be liters because I'm solving for volume and I have to match the unit that I was in before. Okay, so this is going to be my answer. All right, so a lot of these you just have to identify your variables and then plug it into the equation. Okay, we're going to cross multiply and divide. Okay, I'm going to do the next one with you. Okay, so it says I have 7 moles of gas, so that's N. The pressure is 2.3. The temperature is 34 degrees Celsius. Okay, now remember, we cannot use degrees Celsius for for temperature with gases. We have to use Kelvin. So if you do 34 plus 273, that's going to be 307 Kelvin. Okay, I cannot use this degrees Celsius, right? Then it says if I raise the temperature to 50, okay, so my final temperature is 50, but again, I have to have that in Kelvin. So that's going to be 323 Kelvin. Okay, and I reduced the gas to 2 moles, so my quantity of gas has diminished. Okay, now they're looking for what is the final pressure. Okay, so I'm looking for P2. They make zero mention of volume, so I am going to ignore volume. Okay, that's gone. And when I put it into the combined gas law equation, I'm not going to worry about volume. So remember, we had P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. Okay, well, guess what? Volume is not a factor here, so I'm just going to ignore that. Okay, and then I'm going to plug in everything else that I have and what I'm trying to solve for. So I have 2.3 is my initial pressure. My number of moles is 7 times 307 is equal to P2. That's what I'm solving for. And then number of moles final is 2 times 323. Okay, so again, I'm going to cross multiply and divide. Okay, this is a butterfly, and we're going to try to solve for P2 algebraically. So I'm going to do 2.3 times 2 times 323 is equal to 7 times 307 times P2. And again, to get a variable by itself, you have to take everything that's near it and isolate it by dividing it to the other side. Okay, so I'm going to use my phone calculator again. Okay, so we're going to do 2.3 times 2 times 323. And then 7 times 307. And now to get pressure by itself, I'm going to divide this 2,149 to each side. So we're going to have 1485.8 divided by 2149. Okay, so that gives me 0.69 is my final pressure. Okay, so my P2 is going to be 0.69 ATMs. Okay, that's what I just solved for. Okay, so I'm going to have you guys do the last one. Remember, this guy is in Celsius. You have to convert from Celsius to Kelvin. So you're going to have to add 273 for that. Okay. The volume is at 28 liters. I have an unknown pressure, so I don't know what my pressure is. Then we increase the volume to 34. So that's my final volume. The temperature is decreased to 35, so we're going to do 35 plus 273 here. And then my pressure is 2. Okay, so they specifically ask you what is the original pressure. Okay, the original pressure is P1. So you are solving for P1. Okay, so you're going to plug everything in. P1 times V1 over T1. Sorry. This is 318 is equal to P2 is 2 times 34 over 308. Okay, so again, I want you guys to cross multiply and divide. All right, so in your calculator, you're going to do P1 times 28 times 308 is equal to 318 times 2 times 34. Okay, and I want you guys to solve for P1. Okay, thank you.